Hello and welcome to the second part of the rigging tutorials. In this part I'm going to talk about how to rig the legs. In this case it's a little bit different than normal, as we have normal legs but also the stilts. As you can see in the rig, we have the version with stilts where the lower leg is static. And we can have a version that only moves the leg itself and leaves the stilts behind. So let's hide this. And what we're going to try and achieve is that the hip and the calf are going to have the same angle whenever we move it. And then the animator has the option to freely move this angle any way he likes. So we're going to add the foot control, we're going to add an ankle control, and later on we're going to work on the stilts and an option to blend in between the two. So to start off, I'll just hide everything that we don't need at the moment. And then I'm going to use the control UI to start working on some controls. So for instance, I want to start with the crown curve. Just get a little bit down. Make sure we have it placed exactly on the grid. That. Then we're going to create a move controller. So this is going to be the root control, and this is going to be the master control. Group this one and group this one. Give the group sensible names. And then parent the root into the master, and then place them all down below. Then we can select the root control and the joint and just give it a point constraint. So when we move the root control, the root moves with it. Later on we're going to constrain the hips to the hip control. So when we move the root controller, only the root moves. Now we can continue with some foot controllers. And just remove the visibility of the polygons. Place it on the location of the foot. Let's also hide the stilts as we don't need them at the moment. And then scale it up, rotate it so it follows the orientation of the foot a bit. And then make sure that the animator has it easy to select the control curve. So something like this. So now I forgot to group this control curve, and if I group it, the control curve will still have its values, as the group will land in the center of the scene. So I'm going to make sure that I have nothing selected, and I just create a group with Ctrl G, and then the group will be created at the center, but will not have anything in it. So now you can select the curve, you can select the null, do a parent constraint, delete the parent constraint, and I can parent the curve into the null. As you can see, the curve has values, but when I parent them in there, only the scale values are remaining. So then I only have to right click on the scale, to freeze, scale, and now the controller is clean. Call it the left foot control. Group this control. Duplicate, scale in -X. Before we unparent it, we're going to just change the names. Remove them both from the groups and delete the newly created groups. So now, because we scaled it in -X, the X is nicely mirrored, while the rest still moves as we want it to. And before we're going to create the entire IK handle, like we are going to create an IK handle here, and then for the 3 bones down below, I first want to make sure that we have a reverse foot control, so that makes sure that we have all the rotations coming from below, from this control, and like the side, the banking and the foot rolls. So we can do this kind of stuff. And I want to already create a pole vector. So I hide the mesh. And because this is created entirely on a plane, I want to have the pole vector on the exact same plane. Because if I move it somewhere outside of the plane and I attach the pole vector with a constraint to an IK handle, it flips the knee, and that's something we don't want. So I first want to create a polygon tool. I'll just snap the creation onto the bones. Then with T and C I'm going to snap the pivot somewhere behind the knee, and then scale this up, and then I have a nice point where I can attach the knee pole vector in here. Go back to the control creator. Now select the diamond, group it, and position it all the way up front. And then I can delete the plane we just created. Let's call it leg. Now we can group this again, duplicate it, and scale it to -X. Do the renaming part first, then unparent them both and delete the newly created groups. So firstly, let's create the reverse foot chain, and it's just done by creating a single bone, selecting the control, selecting the bone, and do a parent constraint. Remove the parent constraint, and let's start moving this controller, or the joint. So if we show the mesh, we can make sure that it's placed somewhere on the outside of the foot. And this is going to be the position where we do the side-to-side roll for the foot. So it should be somewhere here. Duplicate it and paste it on the other side. Duplicate it, and then somewhere in the middle where we want to have the heel. Then I want to place it somewhere in the exact center of the foot, so we have a pivotal rotation. And now I can hide the polygons again and just snap them to the toe, the ball, and the ankle. So let's give them the reverse foot names. So this one is left reverse ankle, ball, toe. This one's going to be the pivot, the heel. Then we have an edge bank, and we have a center bank. And as you have noticed, all these controls have the same orientation. We're not going to change this, as it makes it easier for us to just follow the rotation of the foot itself. So now I'll just parent them in the order that I created them. And you can see that if I rotate this one in Z and this one in Z, it will move the entire foot in the direction that we want. Just mirror this over to the other side, so we can parent the first one, the left one to the left foot, the right one to the right foot. And then we can start with the creation of the IK handles. But in order to make sure that the hip and the ankle, that they are matching in their angle, we have to convert the 3-bone IK chain into a 2-bone IK chain. And we're going to do that by making sure that we have a 2-bone from the hip to somewhere here, all the way down to the ankle. And the way we do that is just start with the creation. And we're going to rotate this one down 90 degrees and freeze transform it. And we're going to make sure that the Z is pointing towards the other side, so skeleton orient joint, the Z needs to be the -X. The last one is going to be same as the previous one. And then I'm just going to copy the values. So I want to have the length of the knee. So I'll grab the calf, select the X value, and put that into the second joint. And just copy and paste. Now I want to have the length of the hip. So grab the knee and copy and paste it into the last bone. And now for the ankle, or for the calf, I want to grab the ankle, copy the value, and then on this bone, I'll just type in plus is, and then the value, and then it will automatically add it up for me. Now let's go into create IK handle, add the options to the shelf. So when I press the shelf button, it will already give me the options. I want to go for rotate plane solver. Add the IK handle to the newly created bones, paste one to the hip, or move to the hip, move the handle to the ankle, and let's already give it a pull vector constraint. As you can see, it now flipped forward, so I just have to select the ankle or the IK handle and twist it 180 degrees. 180. So now it's back, pointing towards the other side. First delete the IK handle, so we can freeze transformations, make sure that the rotations are 0, give these a nice name. And then we can mirror them to the other side. And I did not. Let's delete the hind leg again, because the last hind leg is not exactly on the position of the ankle. So I have to redo this. Create an IK handle. I can already do the pull vector constraint. I can attach this one to the hip, this one to the ankle. Make sure it's on the ankle. Do a twist of 180 degrees. I can delete the ankle. Let's see, it's still on there. Freeze the transformations and then do the mirror. Now we'll select all of them and change the radius to a little bit bigger, so it's easier later on to select them. Now I'll create the sphere control that needs to be on the ankle. Just create it and group it, place it on top of the ankle, duplicate it and place that one on top of the ankle on the other side. This is going to be the left ankle control. And the right ankle control. Select the bone of the hind leg, then select the control group of the ankle, and just do an all orient constraint. And the same for the other side. So whenever we rotate these, the control will follow. And then now for the IK handles, let's do the rotate plane solver for the hind legs first. Select the hind leg, console select hind leg 2, and it will create the IK handle for us. Let's give it a nice name. Same for the other side. Call it right hind leg IK. Add the pole vector. Also to the other side. And now we can add the twist value for both IK handles at the same time. And we can select both hind legs, parent them to the pelvis, and then open up the foot controls, and we're going to parent the ankle control and the left hind leg IK to the reverse ankle of the left foot, and the same for the other side. So now when we move the foot control, this ankle nicely follows. And we can hide the left hind leg, just to make it a little bit more visible what we're going to do. We can open up the left hip and right hip, and start with the creation of the IK handles as well. So, for the left hip to the calf, so left hip to calf, it's going to be rotate plane solver. Let's do that same for the other side. Right hip, right calf. And then the rest is going to be single chain solvers. So calf to ankle, hit G to redo the same command, ankle to ball, ball to toe, and then the same here, calf to ankle, ankle to ball, ball to toe. So the first one is going to be the left hip IK. And the other side is the right hip IK. It's the left calf IK, or let's call it ankle. This one's going to be the ball. This one's going to be the toe. The other side, same names, different prefix. And then we can close the joints here. Start with the pole vector constraint. And then it's just parenting the IKs to the controls. So in this case we have the left ankle IK also to the control, right ankle IK also to the control. The ball is going to be parented to the reverse ball, the left toe IK to the reverse toe, and the same on the other side. So now when we move the foot controller, the entire thing is moving with it. And the ball or the ankle control can move the rotation, while it will still try to do the exact same movement. And then we can add the extra controllers that control the foot roll, the side to side, and the pivot control. So let's go in and grab one of those special rotation controls. Let's rotate it up. Freeze transform it, make it a group. Just place it a bit above and a bit to the side of the foot. You can even make it smaller if you want. So let's call this left foot roll control. Let's group this, duplicate it, and send it to the other side. Then we can ungroup those again and delete extra groups and just rename them. So I'll parent the group to the foot control, same here, and let's get started on making sure that the connections are working. So I will open the node editor. So I'll need the control, and I need two joints, and add them to the node editor. Just make it a little bit more clean and visible. Expand the nodes. So I want to make sure that when I rotate this in the direction of -z, that this one will also be rotated in -z. But when I select the control and I want to rotate in positive C, this one doesn't go over the positive, but this one will be rotating in positive C. With that, and we're going to achieve that with a condition node, which is in fact just an if statement. So let's create a condition and expand the node. And we know that we want to have the rotate Z of the control, so we want to have that as a term, which just says, if we select it, if this condition, the first term, has something to do with the second term, and in this case we want to have something like greater than or greater or equal. So if my condition, if my rotation of Z is above 0, then it's true. Then I want to do the true. I want to put out true to the next one. So let's say if it is true, I want to have my connection put out to the center bank. So my out color needs to go to rotate Z. But if it's not true, I want it to keep being 0. So if I rotate it outwards now, it should be okay. But if I go -Z, it doesn't do anything anymore. And we can do it with the same condition, we can do it the other way around as well. If it is greater or equal, I want it to keep being 0. But if it's false, I want to port my connection. So in this case, for the second one, I can port out the false connection, which is the out color G, which would rotate Z, which makes sure that it gives the rotation to the first joint when it's positive, and to the second joint when it's negative. Now we're going to do the easiest one, which is just the pivot. It's just selecting the control, selecting the joint we want to pivot around. Let's just close the tab and add the joints again. Expand the node, go for the rotate. For the rotate Y needs to be connected to rotate Y. So when we rotate this, the pivot is rotated as well. But when we want to go into the foot roll, if we go back, we want to do the heel. If we go forward, we want to do either the toe or the ball forward. And to make it work really nice, we want to add a blend in between that. So when we go forward, as you can see here, we might want to first, go first, like only the ball raising, and then we can switch to the entire toe raising, which gives a nice blend feature on how the foot needs to work. And we're going to use the same condition as before, but we're going to add an extra value and an extra node to blend the two values together. So I'll go the tab again, select both controllers to add the weight attribute. So add attribute gives this option, and just give it the name weight. It has a minimum of 0 and a maximum of 1. So we already clamped the values in here. And just add it, and both controllers will have the same attributes added in there. So as I can select this one, it has weight, and this one has weight. So now I can select the bones again. In this case, the reverse heel, the reverse toe, and the reverse ball. Add these nodes, move them over, and then expand all the nodes. And I'm going to add the condition, and I'm going to add the node called blend colors. And as you can see, most of the nodes that I'm now using, they have an out color or a color attribute. We're using them to do the translations or whatever, because colors in Maya are nothing else than just numbers. So in this case we have the rotate X. Going to do the same as we did last time. In the first term, in the color if true, red, color if false, green. Open it. I want to do the greater than, and make sure that this one is set to 0, otherwise it will clamp itself to 1. So we have the rotation backwards, which is negative. There's also negative on the heel, which is great. So if the condition is negative, then it's not true. Then we need to pipe out the color if false, and the color if false, green, can go to the reverse heel. So let's move this aside, test it out first. So that seems to work. Then the color red can go into the blend colors. And this works the same. So we blend from color 1 to color 2. And in this case we want to have one needs to be 0 and the other needs to be the value you want to pipe through. So I'm just going to add the color R to color 1R, and the second one I want to do it to color 2 green. So now it blends from color 1R the connection to 0, or 0 to the connection we have in here. And let's just connect the rotate X to either one of these. So we have R to toe, green to ball. And the only thing we need to add now is the connection of the weight to tell it when to blend. And when we rotate it forward, we can now see that the ball nicely rotates forward. And if we go to the weight and we change the weight, it now blends the rotation over to the toe. And we do the same for the other side. And in the next video I will talk about how to do the stilts and how to do the blending between the stilts.